Good morning, students. Today we are going to discuss about the average and RMS values of a sinusoidal waveforms. So now let us find the RMS and the average values of a sinusoidal waveform shown in figure. Now let us take V of t as Vm sin omega t. This is a standard equation for the sinusoidal waveform. Now, how to find the average value? So, as we know that the average value is 1 by t integral 0 to t f of t dt. But as this is a symmetrical waveform, so when we find the average value for a symmetrical waveform, the time period can be considered as only half the period. Why? Because if you take a full cycle, then the average of positive instantaneous values and the negative instantaneous values you are going to get as 0. So therefore the time period here you have to consider as pi. So therefore the average value 1 by pi integral 0 to pi Vm sin omega t d of omega t, which is equals to Vm by pi. So integration of sin omega t, so is nothing but minus cos omega t, and apply the limits from 0 to pi. So which is equals to Vm by pi minus cos pi plus cos 0. So which is equals to 2Vm by pi. And similarly, what is the RMS value? The RMS value is equals to 1 by t integral 0 to t f of t whole square dt under root. So therefore 1 by 2 pi integral 0 to 2 pi Vm sin omega t d of omega t whole square under root. So which is equals to Vm square by 2 pi sin square omega t can be written as 1 minus cos 2 omega t by 2 integral 0 to 2 pi d of omega t under root, which is equals to Vrms is equals to, now separate the terms and apply the limit Vm square by 2 pi integration of 0 to 2 pi 1 by 2 d of omega t minus integration of 0 to 2 pi cos 2 omega t by 2 d of omega t, which is equals to Vm square by 4. You can take 4 common, so Vm square by 4 pi integration of 1 will get us omega t. Apply the limits 0 to 2 pi minus sine 2 omega t by 2 0 to 2 pi. So which is equals to Vm square by 4 pi into 2 pi plus minus 0 minus sine 4 pi by 2 will get as 0. So therefore under root, so which is equals to Vm by root 2. Therefore the RMS value of a sinusoidal waveform is Vm by root 2, and the average value is 2 Vm by pi. Now the form factor of the sinusoidal waveform, the form factor, if you want to find the form factor, is defined as the ratio of the RMS value of the voltage by the average value of the voltage. So now substitute here Vm by root 2 by 2 Vm by pi, which is equals to 1.11. Similarly, the peak factor is defined as the ratio of the peak value or the maximum value of the voltage divided by the RMS value of the voltage. So now what is the RMS value we got? Vm by the RMS value is Vm by root 2, which is equals to root 2. So which is equals to 1.414. So therefore the form factor of a pure sinusoidal waveform is 1.11 and the peak factor is 1.414 and the RMS value is Vm by root 2 and the average value is 2 Vm by pi. So finally we can conclude for a pure sinusoidal waveform the form factor is 1.11 and the peak factor is 1.414. Vrms is Vm by root 2 and V average is 2 Vm by pi. Similarly, if a full wave rectifier is given, now we are asked to find the average value and the RMS value of a full wave rectifier waveform. So now let us consider V of t. The maximum value is Vm. So let us calculate the average and the RMS value for a given waveform. So find the RMS value and find the average value and the form factor and the peak factor of a given waveform. So so let us take the above waveform. So what is the time period we have is pi. So therefore the average value is 1 by t, that is 1 by pi integral 0 to t, that is 0 to pi Vm sine omega t d of omega t. So which is equals to Vm by pi. So integration of sine omega t is minus cos omega t and apply the limits. So which is equals to Vm by pi minus cos pi plus cos 0. So which is equals to 2 Vm by pi. So therefore the average value we got as 2 Vm by pi. Now similarly, what is the RMS value? The RMS value is 1 by t, that is 1 by pi integral 0 to t 0 to pi f of t whole square, that is Vm square sine square omega t d of omega t, which is equals to under root. So Vm square by pi. So sine square omega t can be written as 1 minus cos 2 omega t by 2 d of omega t under root. So take 2 common. So Vm square by 2 pi integral 0 to pi 1 into d of omega t minus cos 2 omega t integral 0 to pi d of omega t under root. So which is equals to Vm square by 2 pi omega t. Apply the limits 0 to pi minus sine 2 omega t by 2. Apply the limits 0 to pi under root, which is equals to Vm by root 2 pi under root pi minus 0, which is equals to Vm by root 2. So therefore the RMS value we got as Vm by root 2 and the average value we got as 2 Vm by pi. So therefore the form factor is VRMS by V average, so which is equals to Vm by root 2 by 2 Vm by pi, which is equals to 1.11. And similarly the peak factor V maximum by VRMS, so which is equals to root 2. Now similarly find the average value and the RMS value of a waveform shown in figure. I, 2 pi, 3 pi. So let us consider V of t is the input voltage and Vm is the maximum voltage. So now here the total time period is t is equals to 2 pi. So therefore f of t, that is V of t can be written as Vm sin omega t from 0 less than omega t less than pi, which is equals to 0 from pi less than omega t less than 2 pi. So therefore let us find the average value. The V average is 1 by 2 pi is the total time period, integral 0 to pi Vm sin omega t d of omega t plus pi to 2 pi. So pi to 2 pi it is 0. So 0 d of omega t. So which can be written as 1 by 2 pi directly integral 0 to pi Vm sin omega t d of omega t, which is equals to Vm by 2 pi minus cos omega t. Apply the limits 0 to pi, so that is equals to Vm by 2 pi, so minus cos pi is 1 plus 1, so which is equals to Vm by pi, which is equals to 0.318 Vm. The same way also find the RMS value, the VRMS. So VRMS square I am taking instead of root. So VRMS square is equals to 1 by 2 pi integral 0 to pi Vm square sin square omega t d of omega t, which is equals to Vm square by 2 pi. So integral 0 to pi 1 minus cos 2 omega t by 2 d of omega t. which is equals to Vm square by 2 pi Vm square by 2 pi 1 by t omega t 0 to pi minus 1 by 4 sine 2 omega t 0 to pi. So which is equals to Vm square by 2 pi by 2 minus 0, which is equals to Vm square by 2 pi into pi by 2, so which is equals to Vm square by 4. So therefore VRMS square is equals to Vm square by 4. So VRMS is equals to Vm by 2. So finally what we got, the RMS value